the right tax that should be imposed on energy consumption with regard to the vulnerability and the threat to national security of some disruption in foreign oil supplies. Countries can use tariffs for that purpose. They can use import quotas. The problems with tariffs or import quotas is that if you imposed import quotas and or tariffs that really had an impact, instead of looking at current prices of $4.50, you might be looking at $5.50 or $6. And the general population in the United States would find that very distasteful. And that's one of the reasons it still has yet to happen, even though it's in the public interest for those kinds of policies to be designed and implemented. Okay? And as I mentioned, I think in the last lecture, one strategy, the only viable strategy that the U.S. government and other importing countries, Europe in particular, of crude oil have developed to deal with the vulnerability is by holding strategic reserves. And if there was a major price spike, the natural response of the government is to release some flow from that reserve. Okay, very quickly, and I'm certainly not going to hold you responsible for this, there are a number of renewable energy sources that are out there. We talked about switch points between an exhaustible or depletable resource to a renewable resource. There is, for those of you who are environmental science majors, this is a real growth industry, particularly if they can develop the innovations through R&D that will make these sources of renewable energy commercially viable and substitutable for fossil fuels. And very briefly, there's cellulosic ethanol that's out there. Various feedstocks are available. The really key question is, can you convert these feedstocks efficiently into fuels? And I go through here on this particular graph. By the way, with regard to student handout, this is complete. You don't have to fill anything in, right? And that's a clear sign to you that you're not responsible for it. In any case, what I've listed here are all of the biomass feedstocks that are out there, the different conversion processes, and the products that come out through the production process. Different fuels, power, electrical power, and a host of different chemicals that can be generated that have market value. And this is the alternative pathways that exist with respect to biofuel production. This is different processes for making the transformation from the feedstocks into marketable fuels and or power. Other renewable technologies include hydrogen, and the big problem here is storage. And that problem scientifically has still not been solved. But if it were ever solved, we could divorce ourselves from fossil fuels. Electrical vehicles, of which every major automobile manufacturer is offering some products out there, either a dual automobile that can run both on electricity and or gasoline. Solar energy breakthroughs, some of which have happened, but still, but for the subsidies that exist in solar energy, it is not a viable commercial alternative to fossil fuels, at least not yet. Wind energy breakthroughs, the big problem here is the fact that sometimes this source of energy is not available because there's no wind. And there's all sorts of new developments that are out there trying to find the conditions under which this particular technology would provide a viable alternative to fossil fuels. And then there's a long-run set of potential breakthroughs that researchers mostly at academic universities and at various sponsored DOE think tanks are looking at. This is just a list of them. All right, let's move on to today's lecture, namely looking at recyclable resources. And this includes minerals, paper, bottles, whatever. And the fundamental questions that we want to answer during this lecture is, number one, how does the switch point of a recyclable resource differ from that of a non-recyclable resource, presuming that in both instances it's a depletable or an exhaustible resource? Secondly, what is an efficient amount of recycling? Third, will the market automatically generate an efficient amount of recycling in the absence of any governmental intervention? And given everything that we've discussed since the midterm, the answer to this question ought to occur to you immediately. Right? No, the private market will not generate an efficient amount of recycling. And what we want to do is look today at why that is true. And how does subsidization of mineral extraction distort the efficient level of mineral recycling? And what we're going to find here is that the same principles that exist with regard to subsidizing mineral or mining in various parts of the world, the fundamental principles are exactly the same as those we saw when we looked at Brazil's example of subsidizing agricultural production, and that subsidization ending up creating incentives for deforestation and moving the land use from forests to the production of agriculture or food products. And then finally, what remedies can achieve an efficient level of recycling? How do we go about designing the policies that are going to change the incentives for recycling to increase the amount that would otherwise take place, but for those policies that are being introduced by government? Now, to give you a motivation of how important recycling can be, this is a true story. In the late 1970s, there was a very wealthy family by the name of the Hunts in Texas, and there were a number of brothers, 4 or 5, I think only 4, were involved in this particular economic activity. And they were very wealthy not because of their own productivity, but because of their father and mother's productivity, who left their entire wealth to these brothers. One of whom was not involved. He was keenly interested in sports, so he ended up buying the Kansas City Chiefs. But the other 4 decided that the rate of inflation in the United States was going to increase and increase dramatically. And one of the beneficiaries of all that inflation was going to be silver, the price of silver. Right? Now, silver is an exhaustible resource, right? It's also recyclable. I mean, if you have any silverware, you can take that silverware and reverse the production process. You can go back to the raw silver. Okay? Well, the 4 Hunt brothers got together and decided that they were going to corner the silver market. Now, how do you corner the silver market? You take control of all the supply of silver. Okay? But they took control of all of the available raw virgin material of silver. And they did that through 2 means. One, by going out and purchasing silver, putting it into warehouses, going to futures markets for silver, and taking very large positions. And they had, for a short while of time, the market cornered. And the price of silver during this process rose from $5 an ounce to $50 an ounce. And suddenly on paper, these four brothers were worth, what's 50, 10? They were worth 10 times more than they were when the process started. Right? Now, what they failed to realize, when prices of silver were $50 an ounce, it created incentives for people with silver rings, silver bracelets, silverware, silver plates, whatever, to go out and sell their silver at $50 an ounce. And the supply of usable silver in different products was probably 8 or 9 times higher than what the Hunts controlled. So in early 1980, the price of silver was at $50, and within a year, it had fallen below the original price of $5 because they were faced with all sorts of margin calls because they had huge exposure with a lot of leverage in the future markets for silver, and the four brothers ended up bankrupt. An optimal public interest outcome. They were actually attempting to use monopoly power to control the silver market. But that gives you an example of if a particular exhaustible resource is recyclable, one of the driving values of how much recycling is going to be done is what is the price of the virgin material. So in this instance, the price of the virgin material went from 5 to 50, and when it did, it created all sorts of incentives for recycling the various silver products that exist. All right, so let's, with that as background, as a factual, historical perspective about what happened in the case of silver, let's look at the fundamentals. Let's suppose we've got a depletable resource that is recyclable. Let's call the amount of that resource, the stock of that resource, A. And there's some recovery rate. And the recovery rate will be defined as little a. And given that recovery rate, the sum of flows will turn out to be the following sum that's specified here as A plus cap A, little a, and so on, out to infinity. And thus, the total sum of all those flows from that series can be represented quite simply as the amount of the stock divided by 1 minus the recovery rate. It's very simple, very straightforward. Let's see if we can apply this. Okay, this is an active learning example. Let's suppose that the stock of a resource is 100 units, and let's suppose its recovery or recyclable rate is 90%. And the question is, what is the total sum of the resource flows? Now, if you take that simple algebraic result and apply that, you ought to be able to answer that question straight away. What is the total sum of resource flows? Any volunteers? You don't have to visit with your neighbor about this one. This one should be obvious, right? Go ahead. Yes, exactly. The actual computation is very straightforward. Applying that formula, it's going to turn out that if I have an original stock of 100 units and I have a recovery rate of 90%, then the sum of all resource flows is going to be 1,000 units. The real problem here, empirically, is to estimate what that recovery rate is. Right? Given that I have the recovery rate, that's very simple. Okay. Now, with regard to the switch point, there are 3 major things that have to be recognized in the application of this formula. First, if it turns out there is no recovery rate, the resource is non-recyclable. That's obvious. 2, the effect of recycling is to, in effect, increase the availability of the resource. So instead of just looking at the supply of the virgin material, you have to look at that supply plus the supply of the amount that's recovered through recycling. And by the way, that point sounds very simple and straightforward, but the Hunts missed that point in the development of their strategy for cornering the silver market. And unless the recycling rate is 100%, which would imply an infinite amount of the flow of the resource, as long as that recovery rate is less than 100%, the sum of the resource flows, given the underlying resource is exhaustible, will be finite. And since it's finite and exhaustible, ultimately, even though it's recyclable, you will, at some point, achieve exhaustion in the availability of that resource. All right. Now, why is there too much waste disposal? And keeping the following thought in mind. Anybody that's using a recyclable resource has 2 choices. 1, to dispose of it as waste, or 2, to recycle it. It's simple as that. Don't make it any more complicated than that. So anytime in the balance of this lecture, when we're talking about recycling some product, that means we're not disposing of it as waste, and vice versa. Okay? Clear? All right. Now, why is there too much waste disposal? One is that the marginal cost of disposal is not recognized by the decision makers who are making the choice between a waste disposal or recycling this exhaustible resource. The private marginal cost of processing the waste is not recognized. Moreover, you've got to manage that waste. That waste ends up somewhere. It ends in landfills. It ends up reducing the aesthetic value of various lands. And it also, for many recyclable resources, results in health hazards. And that's certainly true of lead and mercury. Batteries, for example. All of us are familiar with batteries, particularly we become more familiar with them when the batteries aren't working, right? Or the battery power's gone to 0. Many of those batteries have lead embedded in them. So now the question is, how do I go about managing the waste when I dispose of those batteries? I can throw them into trash cans and they're picked up and they migrate or are transported to landfills, or I can recycle them. Okay, so when we look at the waste disposal process, every city, every community has a trash collection company that's involved in collecting all of that trash. And the question is, how are they compensated? Generally speaking, what local communities do is collect property taxes and then use some portion of the property taxes to cover the cost of the waste management or the waste disposal. And that is, generally speaking, a flat rate fee. And we ask ourselves, wait a minute, if when I'm making the choice between recycling and waste disposal, and I don't see the actual incremental cost associated with waste disposal, how is that going to affect my behavior? I mean, that's the fundamental question. Right? And if the marginal cost for waste management or waste disposal is not constant, and instead rises with the amount of waste disposal, but I don't incur that incremental cost, it's not going to change my behavior. Right? So the various policies that are out there either property taxes or charging some flat rate, it turns out that every individual or household will look at those two policies and behave as though the marginal cost of waste disposal is zero, because it is, in terms of what they incur, right? And as a result, there's going to be too much in the way of allocation of these recyclable resources into waste disposal. Let's take another example, namely one in which there's flat rate pricing and why that ends up creating too much in the way of incentives for waste disposal. Let's suppose in your city that you pay $150 a year in taxes, and if you're renting, it's built into your rent, right? But it is a flat rate. And now the question is, what would be the amount of disposal resulting from that payment of $150, that flat payment, would that lead to an efficient amount of waste disposal? Visit with your neighbor, give it some thought. Based on the arguments I advanced in the prior slide, you should come to the conclusion, well, you can come to whatever conclusion, we'll wait. Yes. Pardon? I'm sorry? You have? Go ahead. What's the question? Okay, but that's not crude oil, right?
It says here, heating oil and diesel fuel. So it's like refined.
Yes, right.
Yeah.
It's refined products, and if it turns out that there's very warm weather here, then heating oil, the demand for heating oil is not that much demand, so you've got to dispose of it somewhere, and you dispose of it at world markets. In addition, much of the diesel fuel comes from corn-based products or soybean-based products here in the United States now, so it's not crude oil, fossil fuels.
So it's not like just a word. It's just refined.
Yes. Pardon?
Doesn't it make sense why they'd be exporting it?
Yeah, but it's not very much. That's enough. Okay, volunteer? Any volunteers? There we go, thank you. If the marginal cost is zero, you're saying, yes, exactly. So they don't actually see any incentives for adjusting their behavior. And when we look at the private marginal cost, it is not the same as the social marginal cost, even if we did have some marginal private cost, but we don't even have that here. And with flat rate pricing, as you said, the private marginal cost of throwing things out or disposing them as waste is zero. By the way, assuming no peer pressure, right? You know, when I was your age, you could drive down the street and you could throw paper out your window and no one would look as though you should be ostracized. If you did that today, the peer pressure is pretty phenomenal, right? Anyway, so we're sweeping aside peer pressure here. But it turns out even though your private marginal cost is zero, the social marginal cost to society is not. And as a result, at least for a material portion of the population, there will be bias. That major portion of the population will be biased in the favor of throwing away as waste rather than recycling whatever is available that can be recycled. And littering, as I just noted, is an extreme example of a zero marginal cost problem aside from peer pressure. And it shouldn't surprise us that we can conclude with the private marginal cost of zero, the amount of waste disposal, what actually happens, will exceed the most efficient level. And now we want to look at this in a concrete way. And fortunately, there's an actual experiment that was run by the state of Georgia on trash pricing or waste disposal pricing. Before the experiment was conducted, it turned out that there was a flat rate of $15 a month, namely marginal cost of zero. And then they introduced two different pricing schemes for trash collection. One pricing scheme was you pay an $8 monthly fee, which again would be flat, right? It doesn't reflect any marginal cost, but 75 cents per bag. So now we've got the possibility of the household or individuals looking and recognizing that there's some marginal cost to them of disposing of products as waste. Scheme two, they fixed the monthly fee based on a predetermined maximum number of cans the homeowner wanted or wished or said that they wanted to use to store their recycled products, and thus presumably end up with less generation of disposed waste. Okay, now, the question here is, would you expect these two different pricing schemes to reduce the amount of waste disposal? And indirectly, if they reduce the amount of waste disposal, they're going to increase the amount of recycling, right? Because those are the two fundamental choices.